All right, we're gonna do a second section on volumes of cross sections. So we're basically just expanding the shapes a little bit. We're gonna be working with some triangles. It'll be good practice to try cross sections for another day. So the idea again is I'm gonna give you some kind of shape in an XY axis. So this is only 2D. We're finding this area, or between this bounded region, we're gonna make volume stick up out of the paper. And so the base of those like shapes we're drawing is going from the top minus bottom, this line right here. Again, there's no white space or any like thing to subtract from the volume. So what happens is, for today, we're gonna make some triangles. So we're imagining triangles coming up out of the paper, sticking up out of the paper here, a bunch of little triangles kind of packed together. So let me try and draw it 3D. This shape right here, like something like this. And then this black line would be like this. Now let's see there's different ways we could describe triangles coming up out of the paper. The first way would be if I said the triangle's an isosceles right triangle. An isosceles triangle has two sides the same. And if it's an isosceles right triangle, then there's a right angle. So this length and this length would be the same coming up out of the paper. And then we could imagine there would be like a bunch more triangles in this shape here, all throughout here. But we don't have to picture the 3D shape here. All we need to do is find the volume of this situation, and that situation would be a triangle's area, which is 1/2 base times height from A to B. That's our intersection points that we need to find the intersection of from the calculator. Except if this is an isosceles triangle, then the base, this length, is the same as the height, this length. So technically, you can just, you could simplify that and just say like base squared or something like that, and that would represent the same thing. What you need to know is like, how would I find this baseline? Well, this baseline is this line right here. And we know to find the length of this, it would be top minus bottom. So let's say the top is f of x minus g of x would give us this line, which is the baseline here. So technically the formula would be I guess better off to say it's like 1/2 top minus bottom, and then since it's base and height, this line and this line are the same, squared times itself. And that's maybe a better formula there. So let's put that into our notes here. So this is our baseline right there, but it's the same as the height. So the formula would be 1/2 top minus bottom for the base times the height, which is the same, so squared. Okay, and there we go. All right, now the next one we have, I'm gonna use the same picture up here that we're working with, but this time we're not gonna use this anymore because this was an isosceles triangle. Let's say this time the shape is, let me try and draw it 3D. Again, okay. This time we're still doing a triangle and it's still an isosceles right triangle, but this time what it's saying is the hypotenuse is this line right here. So this line up here, up and down, is the hypotenuse of the right isosceles triangle. So the right angle then would be right here, and then this side and this side would be the same. So this would be my shape right here with thickness dx. Well, that changes some things now with the formula. To find the base and the height here is now like, it's not as known as before. But basically, let's see if I'm setting it up as a triangle. The base would be the length from here to here. The bottom, nice and dark, I like to draw it, again, is the same as this up and down line. So this line is top minus bottom. So there's the base of the triangle, top minus bottom would be this. Now the height, this is gonna use some trigonometry here, or some special right triangles. The height here, what we've done is drawn this at a 90 degree right here and created another little 45, 45, 90 triangle. So that means this little side and this little side are the same. So if I want this side, I just need to find this piece right here from here to here, and it's the same as the height going up and down out of the paper. Well, this little chunk is only half of the top minus bottom here. So I just have to do top minus bottom divided by 2 to get from here to here, which was, again, is equal to going up here to here, the height. So this is the full base, and then this is half the base, which is equal to the height. So base times height times dx. And then we could technically simplify this to this 1/2 and this half. I could put the halves together to make 1/4, which would leave a top minus bottom here times a top minus bottom here, or I could just square it. And now that's technically my simplified formula for this scenario. Personally, when I do these problems, I don't think of the formula because it doesn't look intuitive about triangles. I just try and break it up the way I've done here. But let's go into the formula here. It would be, I'm gonna write it 1/2. The base is top minus bottom times the height, which is top minus bottom's length divided by 2 dx. I'm gonna write it like that. I know that's not the simplified version, but that's the version that seems to make more sense to me. So this is what we're finding for my height here. Alrighty, okay, one more to go. This time, we're not gonna have this shape anymore. We're gonna use this same picture here, but this time, I'm gonna try and draw it 3D as best as possible. So this little shape here. This time, it's gonna be an equilateral triangle. The base line here is this line going up and down here. But the equilateral triangle has all 3 sides the same. There's no, so this side, this side, this side are all the same. There's no right angle at any point on this. Instead, let me just kind of like show you what what an equilateral triangle looks like. So here's this black line on the bottom is my black line here, which is this black line here. Okay, so we know we have an equilateral means all sides are the same. It also means all the angles are the same. So if they add up to, the angles add up to 180 and I divide by 3, that makes 60 degrees for every angle. So when I want to get the area of the triangle, it's 1/2 base. The base is this black line, which to get that black line, we do it from doing top minus bottom. So the base is f of x minus g of x, okay, times the height. So let me just write that length here as f of x minus g of x. Line right here. So there's 1/2 base, and then times the height. The height is this line that we would need on our triangle. And to get that, I've drawn a 90 degree down the middle here, which splits this 60 up into a 30 right here. Now we got a 30, 60, 90 triangle here. This is the small side just from here to here. I'm just working on the left triangle or right triangle here. So this length right here is f of x minus g of x divided by 2. on this half of the side. To go from this small side to the height, the medium side, I would have to take that side and multiply by a square root 3 to that. Then that's just hopefully something you know from the special right triangles. You take the small side and multiply by rad 3. So I'm going to just put this height into my formula of 1/2 base times height. Okay, now that I have all these pieces of information, I can set up my integral here. 1/2, the base we said was f of x minus g of x. That's this length right here. And then the height is a rad 3 over 2 piece times the f of x minus g of x. I'm going to just take the rad 3 over 2 and put it together. And then it's multiplying to the f of x minus g of x times dx. So that's just one way of writing it. Instead of putting like this divide by 2, I just pulled the rad 3 and the 2 together times the f of x minus g of x. Now if I want to simplify all this, it would be on top I've got a rad 3 times 1, on bottom a 2 times 2, and then the leftovers are f of x minus g of x, and then another f of x minus g of x. So I can just take that and square that instead of doing times itself. And there's our formula there for the equilateral triangle. Let me put that into our notes. So rad 3 over 4 f of x minus g of x squared. And there's the formula.